and A is 45 meters. And A is 45 meters. C is 75 meters and A is for 45 meters. So it says that we must find all the six trig ratios. So if it says we must find all the six trig ratios, it's talking about cos, sec, sine, cosec, um, tan, and cot, and cot. So obviously, and now we know A is 45 and C is 75. So we must find B. How do we, before we can find the trig ratios, at least we must know B. We must know B. And we know that we can use Pythagoras theorem to find B. That is C squared, which will be 75 squared, which will be 75 squared, will be equals to A squared, which is 45 squared, 45 squared plus B squared, which we don't know. So we can say that B squared, we can say that B squared is equals to square root of 75 squared, 75 squared minus 45 squared. Then if we simplify this, we can easily see our answer to be um, let me see. We can easily see our answer to be 60 meters. To be 60 meters. To be 60 meters. Then once we know this, now we know A, C is 75, A is 45, and C is and B is 60. So if I can draw my right angle triangle again, if I can draw my right angle triangle again, I know here is B, here is A, and here is C. Now I know B is 60. Um, I know B is 60. A is 45. A is 45. And C is 75. So now I can easily find my cos B because I'm finding the reference angle B. So cos B, as I know, is adjacent to the angle. So if I'm talking about this angle, my adjacent to be this one, and my equal to be this one, and my hypotenuse to be this one. So it will be adjacent 45 over hypotenuse 75. Then This one can be simplified to 3/5. Then I can go to sec theta. I know that sec theta is the reciprocal of cos theta. Then the sec theta will simply be 5/3. Then sin theta. Sin theta will be opposite of hypotenuse. So it will be 60/75, which will be 4/5. So cosec theta, cosec, no, sorry, it's B, ne? Sin B. I'm so sorry. Here is B. We are looking at angle B. So cosec B will be the reciprocal of sin. It will be 5/4. Then tan theta, sorry, tan B, sorry. Tan B will be opposite over adjacent. So it will be tan B will be 60/45, which will be 4/3. So cos B will be 3/4. Please, any questions so far? Any questions so far with the three trig ratios? Sorry, six trig ratios. Or we can go on. Can we go on? Can we go on, please? Yes, can we go on? Any questions or we can go on?
You can go on, sir.
Okay, go on. Okay, thank you. Now let's look at on the same activity 4.1. Let's look at the last question. That is um question 5. So now if we look at question 5, it's the same triangle now. It's the same triangle. And we have A, B, and C. But if you can look at question 5, now it says we must use angle. Sorry, question 4. Question 4. Sorry, it says we must use angle A. So if we are using angle A, then this time here will be your opposite. A will be your opposite. B will be your adjacent, and C will still be your hypotenuse. Now, we can see here that it gave us A to be 29 millimeters, A to be 29 millimeters, and B is 47 millimeters. B is 47 millimeters. B is 47 millimeters. So we can simply use Pythagoras theorem to find C. So if this side is 90 degrees, we can say that C squared equals to A squared plus B squared. So C squared will be equals to 29 squared plus 47 squared. Then we can just find the square root like this. Then we can easily see that our C is going to be a minute. We can easily see that our C is going to be 55.2. Our C is going to be 55.2. Please don't forget the unit is millimeters. It's millimeters. So here, if I can draw my triangle again, I have my A, my B, and my C. And I know that my A is 29 millimeters. My B is 47 millimeters. 47 millimeters. And my C is, as we have found recently, 55.2 millimeters. 55.2 millimeters. So now we are finding it in reference to angle A. So this one becomes opposite adjacent hypotenuse. So cos theta or cos A will obviously be 47 over 55.2. 47 over 55.2. 55.2. And sec theta, which is the reciprocal, or sec A, which will be the reciprocal, will be 55.2 or 55.2 over 47. Then sine A will be 29 over 55.2. And cosec theta or cosec A, which is the reciprocal, will be 55.2 55.2 over 29. Then tan A will be opposite over adjacent, which will be 29 over 47. And cot A, which is the reciprocal, will be 47 over 29. Okay, good. So that is how and Pythagoras theorem. So in the absence of no questions, we are going to go to activity for activity 8,2. We are going to go to activity 8,2. And activity 8,2, these are not special angles. So we can simply punch on our calculator. And the I think the most striking ones is number 4, 5, and 6. Where we have number 4 is cot 34. Is cot 34.6. Number 4 is cot 34,6, which will be the same as 1 over tan 34,6. We just punch 1 over tan 34,6. Then the next one is cosec 56. Cosec 50, cosec 56, cosec 56 will be the same as 1 over sine 56. Then the third one we have sec 78,09. Sec 78,09. Sec 78,09, which will be the same as 1 over cos 78,09. So we know those dynamics. Please, any questions so far?
No questions there.
Okay, good. Now, in the answers of no questions, the next one is that use our calculator to solve the following correct to 2 decimal places. Good. So here on your calculator you can find inverse. So the first one, activity 8,3, we have cos A, we have cos A, cos A equals to cos A equals to 0,859 equals to 0,859. So on your calculator, we can find A equals to cos inverse cos inverse of 0, 859. Then you can just punch on a calculator. So you can do for the rest. It's very simple and straightforward. Now, when we come to solving right angle triangles, there are examples you can look at, but I would like to look at activity 8,4. Now it says that we should solve the following triangles. And as already said, when you are asked to solve a triangle, you are simply being asked to look at all the sides and all the angles. Now you have got side A, side A, and side C. Now here too, I'm going to look at question 1 and question 3. Now we have got the same triangle like this. We have got the same triangle like this. Where we have B here, A here, and C here. So here will be B, here will be A, and here will be C. Now, let's go on. We can see that A is equal to 0,6341. A is equals to 0,6341, and C is 0,7982. C is equals to 0,7982. So using C squared equals to A squared plus B squared, we can say that C, we can easily, if you want to find B squared, we can say that B squared is simply the square root of what do you call it? 0, 0,7982 squared minus 0,6341 squared. Now, if we simplify this, so it will be not B squared, sorry. So we can easily see that our B is going to be our B is going to be 0,48. Is going to be 0,48. So once we know this, it will be easy to find the angle. For instance, I can say that tan E is opposite over adjacent, which will be A over B. So A will simply be equals to tan inverse. Tan inverse of 0, 6, 3, 6, 3, 4, 1 over 0,48. Then you can easily find angle B, angle A. Then I want to find C. Um, if I want to find C, I can say that my C is going to be, let me write down the triangle again. We have a triangle like this. We have A, B, and C. So here will be B, here will be A, and here will be C. So I can say that B is equals to adjacent A over C. We know A, we know C. So B will be equal to cos inverse. Cos inverse of A over C. Then if I come to C, I can still say cos C. Cos C, but what I'm talking about, no, we don't even need to find C because C is the right angle. 20 degrees. We don't want to be as a right angle. So please, are there any questions there for right angle triangles? Are there any questions there for right angle triangle?
No questions, sir.
Okay, good. Then we have got some activities in question 8, comma, point 6. Question 8 points, activities 8.6. There are some questions that have been done for you, but we are going to look at those questions there. Now, these are word problems where you are going to apply the trig ratios and what do you call it, Pythagoras theorem to be able to solve them. Now, 8.6 on page 15. The first question says, a car travels a distance of 500 meters up a hill, where the hill makes an angle of 20 degrees with the horizontal. If the car was originally at sea level, find the height it is above sea level. So you have your car here on the ground like that. Then it traveled uphill. That will be the car. Traveling uphill. And it says that it traveled uphill on an angle of 20 degrees. 20 degrees. And uphill, it traveled for 500 meters. 500 meters. 500 meters. 500 meters. So now the question says that we must, so please, you have to know that on the ground is the sea level. So you say that if the car was originally at sea level, find the height if it is above sea level at the end of the journey. So it is very simple. We are looking for this side, the height here, which is the opposite. So here clearly we are going to use sine 30 or sine 20 will be equals to the height over the hypotenuse, which is 500. So our height will be equals to sine 20 times 500. Then we can punch our answer. Please, any questions with the question 1? Please, any questions there?
No questions, sir.
Okay, good. Now, our next one says that a ladder is 6 meters long, leans 6 meters long, stands against a wall of a house. So, and it is inclined to the horizontal at an angle of 60 degrees. So, here is your wall. Here is your wall. And there's a ladder that is leaning against the wall. Now, the ladder, as they said, is making an angle of 68 degrees with the horizontal. And the question says that the ladder is 6 meters long. So now it is asking the question is asking how far does it reach up the hill? So clearly it's asking of this height. So here too we can use the same sign. Sine 68 equals to hypotenuse, sorry, the height over the hypotenuse, which is 6. So the height will be equals to sine 68 times 6. Then we get our answer. Now let's look at the next question. The next one says that a square has a diagonal of length 8,5 meters. How long is one of its sides? Now we know on number 3, we know that a square, we know that what do you call it? We know that a square has got the same side. We know that a square has got the same size, and it has got a diagonal. They say it has got a diagonal like this and a diagonal like this. Now the question is saying this that the diagonal is 8.5 centimeters. This diagonal they are talking about is 8.5 centimeters. 8.5 centimeters. The diagonal is this one and this one. So now our question is the question they are asking here is what is the length, because the sides are equal. The sides are equal. So now the question they are asking is that what is the length of each side? What is going to be the length of each side? So or how long is one of the length, because a square has got the same length. So with this question, we have to understand some basic properties of a square. As I've said, um, a square has got all four sides equal. So let me put it very simple. That for a square, if this side is x, this side is going to be x, this side is going to be x, and this side is going to be x. So I can take this side because I'm looking for x. So I can take only this side. You see, then I can have um, this. I can have this one. I can have this one. Then I can have this one. Then I know that here is x. Here is x. Then the hypotenuse is 8.5. Then obviously I can use Pythagoras theorem. 8.5 squared. 8.5 squared will be equals to x squared plus x squared. So 8.5 squared can be equals to 2x squared. So we can easily work this out ourselves. Please, any questions with this one? Please, any
No
questions so
questions.
far? Okay, good. So you can see that all the examples we are using, we are applying Pythagoras theorem, or we are applying the trig ratios. We are applying Pythagoras theorem or the trig ratios. Now let's go to question 4. Question 4 says that a ladder leans against a wall. It is held in place by a piece of string tied to the bottom of the ladder and a hook at the bottom of the hole. A string. First, let's try and get a picture of the question. It says that a ladder. We have got a ladder which is leaning against a wall. So now, if let us say here is the wall, we have a wall like this. Then there's a ladder which is leaning against the wall. Now, the question goes on to say that it is held in place by a piece of string to the bottom of the ladder and a hook at the top of the wall. That means that the ladder is held in place by a string and on the top of the wall by a hook so that the ladder will not fall. Now it says that the string is 1.5 meters in height the top of the ladder rests on the wall sill, and the ladder makes an angle of 45 degrees with the horizontal. How far is the window sill from the ground? How far is the window sill from the ground? So here we know the angle that the wall is the ladder is making with the wall, and here it says that 75 degrees is making an angle of 70 75 degrees. Now, if I may ask, do we know the length of the ladder? Do we know the length of the ladder?
No, we don't know the length of the leg.
Okay, good. So can you see that 1.5 will be this string? You see that there is a string from the wall to the ladder. So that means that here is going to be 1.5. Can you see that? Can we all see that?
Yes.
And it says that it makes an angle of 75 degrees. It makes an angle of 75 degrees with the wall. It says that the ladder makes an angle of 75 degrees with the horizontal, sorry. So here is going to be 75. So in that case, we can the question is asking for how far is the window sill from the ground. So obviously it's asking for the height here. Have you seen? So here we can use cos 75. No, sorry. We can use because we have opposite and adjacent. So we can say tan 75. Tan 75 equals to opposite h over 1.5. So h will be equals to 1.5 times tan 75. Please, it's important to know that as all the questions we are doing, we are working in degrees. So your calculator must always be in degrees. Must always be in degrees. So please, we can go on and on and on. The questions are all the same. Okay, so let's look at the last question, question 7. Then you can look at question 5 and question 6 yourself. Now, question 7 says that a man is standing on top of a cliff 150 meters high. He observes a boat. Um, he observes a boat traveling at 40 kilometers. He observes a boat traveling at 40 kilometers. Um, he observes a boat traveling at 40 kilometers per hour, leaving the base of the cliff. Sorry, leaving the base of the cliff. He watches it for 1 minute, moving in a straight line. Find the angle X in the sketch below. Find the angle X in the sketch below. Of the boat after this time. Good. So let me try and see whether I can draw this sketch. Now this sketch looks like this. We have this line. We have this line. Then we have this line. Then there's a line like this. Where here is X. Then we have given here to be 150 meters. 150 meters. Then the boat was here initially and it traveled to here. Now the boat was traveling at um, a speed of 40 kilometers per hour. 40 kilometers per hour. And it traveled for 1 minute. Okay, good. So now we need to we know that speed is distance over time. So distance is equals to speed times time times time. So now we have the distance to be 40. Now we have to remember that we must convert this time into hours, and converting time to a minute to hour 1/60. It will be 1/60. Our distance in kilometers will be 2/3 kilometers. Now 2/3 kilometers is going to be 0, let's say 0.66, if I'm not mistaken. 0.66 kilometers. Now we need to convert this because this one is a meter. We need to convert these kilometers to meters. 0.66 kilometers is going to be 660 meters. Will be 660 meters. Now now with this 660 meters, you can see that now if we can find this angle and subtract from 90, we get this angle. So now we have opposite and we have our opposite and we have our adjacent. So I can say that tan theta will be equal to opposite 660 over 150. Then whatever answer we get, we find tan inverse. Theta will be equal to tan inverse tan inverse of 660 1, 150. Then whatever answer you get here, you simply subtract from 90 because this angle will make an angle of 90. 0 subtract from 90 and you get the angle x.
Sir, you're breaking.
Okay, good. I'm saying that whatever angle you get here, né, you see, we can use tan theta because we know the opposite, we know the adjacent. So once you know this angle, you can use tan theta to find this angle. Then this one makes an angle of 90 degrees. So you can, whatever answer you get here, you subtract from 90 and you get the angle x here. So that will be that. Solving what do you call it? Right angle triangles is very, very simple. Now, the last thing that we found challenging was converting special angles. And as I said, before we go to special angles, please, any questions? Before we go to special angles, please, any questions? Any questions, please, before we go to special angles? Okay. Now, I have already told you that when we come to special angle, we are going to work with um, radians a lot. Now, I believe right from the high school, you were taught what special angles. They are simply angles that you can easily um, find without using the calculator. For instance, if I draw the special triangle, if I draw the special triangle like this, if I draw the special triangle, then if here is 1, and here is 1, here will be 2, then here will be 45, here will be 45, and here will be 90. Then there is the second special angle, which is like this. And it's like this. It's like this. Where here will be 30, 30, 60, and 60, 60. So in that case, here will be 2, here will be 2, here will be 3, and here will be 1, and here will be 1. So you can easily say that cos 45, cos 45 is going to be 1 over or 2 over 2, the same thing. Sin 45, sin 45 is 1 over root 2, that is opposite over hypotenuse. Then and 45 is 1. It's a special angle. Or a special angle. Then other special angles we can talk about sine sine 60 is opposite over hypotenuse. So 60 is the opposite over hypotenuse. It will be root 3 over 2. We can talk about cos 60. Cos 60, which is adjacent over hypotenuse. Then we can talk about tan 60. Equals to opposite over adjacent, which will be root 3. Then another special angle we have is 30 degrees, sine 30, sine 30. It's a special angle. 30 is here, so opposite over hypotenuse. We are going to have 1 over root 1 over 2. Sorry. Then we can have um, cos 30. Cos 30 is adjacent over hypotenuse, root 3 over 2. Then we can talk about tan 30. Tan 30 equals to opposite over adjacent. Opposite over adjacent. So this will be 1 over root 3 or root 3 over 3 when we rationalize. So these are the special angles. But as I've told you, when we come to special angles, we are not going to work in degrees a lot. We are going to work in radian. We are going to work in radian. In radian. So you must get yourself used to radian. Then so if we have, I told you that if you want to convert from, if you have an angle theta and you want to convert to radian, it's pi.
Sir,
Hello.
you're not clear. I think you're blocking your mic when you speak.
Okay, am I clear now? If I'm not clear, please quickly draw my attention. Is it clear now?
Yes.
Okay. So it will be pi over 1/8 to convert from degrees to radian. So for instance, if I have 30 degrees and I want it in radians, it's going to be times pi over 1/8, which will be equals to pi over 6. Then another special angle, if you have 45 degrees, then you want to convert to radians, it is times pi over 180, which will be the same as pi over 4 in radians. Then the last one, if I have 60 degrees and I want to convert to radians, it will be times pi over 180 times pi over 180, which will be equals to pi over 3. So, in the same vein, yes, Rainy,
So what did you write here? I'm just going to show you here. What did you write here?
pi times pi over 180.
Is this 30 equal pi over 180?
Oh, sorry, is times. That is converting from degrees to radians. Is that clear?
Yes, sir. Thank you.
Okay, good. Now, in the same way, if you have angles in degrees, for instance, if you have pi over 4, it's in radians. Now, if you want to get its value in degrees, it is simply 180 over pi. Then this pi will cancel this pi. 180 divided by 4, we are going to have 45 degrees in degrees. Then, in the same way, if you have pi over 6 in radians, then you want to convert to degrees. It is simply 180 over pi. Pi will cancel pi. Then 180 divided by 6, we are going to have 30 degrees. Then the last one, if you have pi over 3, it will be times 180 over pi. This pi will cancel this pi. Then you are going to get the answer to be 60 degrees. So that is how we interchange between radians and degrees and degrees and radians. So I believe you have come across questions where you have been told that without using a calculator, but if you can look at the angle is not a special angle. So let me bring into sharp focus when you were back in high school, you did what we call the cast. Now, as I've said, we are going to work in radians a lot now. So here will be pi over 2, here will be pi, here will be 3 pi over 2, and here will be 2 pi. So in essence, pi over 2 is the same as 90 degrees, pi is the same as 180, 3 pi over 2 is the same as 270, 2 pi is 360. Then we have the cast. I believe all of you remember the cast. Cast means that from 0 to pi over 2, every angle you measure, you find a trig ratio of is positive, whether it's cos, sine, tan, or positive. But here, if you find a trig ratio, only sine will be positive, the rest will be negative. From between pi and 3 pi over 2, if you find a trig ratio, only tan will be positive, the rest will be negative. And between 3 pi over 2 to 2 pi, that is between 270 to 360, only cos will be positive, the rest will be negative. Please, any questions with the cast that I've drawn there? Please, any questions with the cast that I've drawn there? Okay, that means that we can go on. Now, we also have to note that the clock, ne? The clock goes in this direction. So we call this one clockwise. Then when you have something like this, we call it anti-clockwise. This is clockwise, clockwise. We call this one clockwise. We call this one anti-clockwise. 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 Now, we have to also um, note that when you have an angles can be positive and negative. So let me just give an example. If I give you an angle like this, minus minus 45 degrees. Minus 45 degrees is the same as minus pi over 4. So if the angle is negative, you measure it will be here like this, pi over 4. If it's negative, you go in the clockwise direction. But if I have a positive pi over 4, then we measure in the anti-clockwise direction, like this, pi, pi, pi over 4. So it is very important that in us always trying to find our reference angle, you must note that when an angle is negative, you measure in the clockwise direction. When an angle is positive, you measure it in the anti-clockwise direction. It's very important for you to know that. Then you have to know that angles are always measured against the x-axis. That is against 0 and 180, or between 2 pi, in that order. It's important for you to know that angles are always measured against those that line, the x-axis. And it's one thing too I would like you to note is it's important for you to know that trig graphs are um, periodic graphs. When I say periodic graphs, what do I mean? Let me just use degrees so that you see it clearly. If I have 0 here, here will be 90, here will be 180, here will be 270, here will be 360. Then when we come back here, we come to 450. Then we come to 540. So it goes periodic like that. Have you seen? Then we come back to 630. Then we come to 720. It can go on and on and on and on and on and on like that. That's what we call is periodic. Have you seen? It goes on and on like that. So let me just pick a simple question and let us try and find a reference angle. So if I have an angle like this, um 120 degrees, 120 degrees. Remember that when I was mentioning special angles, we never knew 120 degrees to be a special angle. Have you seen that? We never knew 120 degrees to be a special angle. So if I'm asked to find this angle without using a calculator, what I will have to do is that I must first find what I have been mentioning to you as the reference angle. The reference angle. Please, it's very important. The reference angle. Now, to find a and every reference angle is always a special angle. Every reference angle is always a special angle. So here, let me just, here will be 0, here will be 90, here will be 180, here will be 270, and here will be 360. So 120 degrees is positive, so I'll measure in anticlockwise direction. 120 degrees will be somewhere here. So here will be my 120 degrees. So you ask yourself, what x-axis is the closest to 120 degrees? It's 180 degrees. So now that means that my ref angle will simply be 180 minus 120, which will give me 60 degrees. Now, once I know I have found my reference angle to be 60 degrees, I can find any trig ratio. Have you seen that? So that is all that they mean when they say without using a calculator, find the reference angle. Is that clear? Any questions on how to find a reference angle? Please, any questions? Please, any questions?
degrees. Sir, I don't know if I'm the only one, but I can hear you.
Okay, can you hear me now?
Yes, so now I can hear you.
Okay, good. Please, can all of you hear me? Okay, good. So now our angle, because is negative, we go in the negative direction. Have you seen? And here is going to be 45. Here is going to be 45 here. Now the closest angle, the closest x-axis to 45 is 0 degrees. So it's simply the reference angle. The ref angle will simply be 45. The ref angle is 45 minus 0, which will give us 45 degrees. So the negative sign simply tells us the direction where the angle is going to go, whether it's going to go in the clockwise direction or the anti-clockwise direction. So if we can pick an example like 5 pi over 4. 5 pi over 4. Let's take 5 pi over 4. Um, 5 pi 5 pi over 4. So you can see that here we are working in radians. So you can be asked to find the trig ratio of this angle without using a calculator. And as I've said, once they mention that word without using a calculator, all that they are asking for is for you to find the reference angle. So how do we find the reference angle? We draw our cast. This time we are working in radians. So that means that here will be 0, here will be pi over 2, that is 90 degrees. Here will be pi 180 degrees. Here will be 3 pi over 2, 360 degrees. And here will be 2 pi. Now, I know because most of you, you are not conversant with radians. At times, it might be difficult for you to know which quadrant will this 5 pi over 4 will fall. So if you are not sure, just quickly convert to degrees and see. 5 pi over 4 times 180 over pi. 180 over pi. Pi will cancel pi. Then 45 times 5 will give us how much? 5 over 4 times 5 will give us is it let me see,
225.
225. That means that it will lie between pi and 3 pi. Is that clear? So that means that this 5 pi over 4 is going to be lie here. This 5 pi over 4 is going to lie here. This 5 pi over 4 will fall here. You see? 5 pi over 4. So our closest x-axis is pi. Have you seen that? So our reference angle will be here. So that means that, as I've said, if you anytime you find a reference angle, you must get a special angle. So your reference angle will simply be 5 pi over 4 minus pi. Then you find out that the answer is going to give us pi over 4. So once you have found a reference angle, it will be easy to find the trig ratio of any angle that is pi over 4. Have you seen that? So anytime they tell you that without using the calculator, that is the literal meaning. Find the reference angle. Once you find a reference angle, it will be easy to find any trig ratio, because now your reference angle always gives you a special angle. Please, any questions there? Okay, in the absence of no question, let's look at another example. Now, another example, we have negative 7 pi over 6. We have negative 7 pi over 6. Now remember, I said if it's negative, we always move in the clockwise direction, positive anti-clockwise direction. So we draw our cast like this. Then we have what do you call it? We are going to have 0, because we are working in radians, 0 pi over 2 pi 3 pi over 2 and 2 pi, like this. So with this, we can see that as I say, if you are not too sure where 7 over 6 pi is, just convert to degrees. So 7 pi over 6 times 180 over pi times 180 over pi. Pi will cancel pi. So what will be 7 over 6 times 180?
210.
210. Good. So remember that this time we are moving in the clockwise direction. So we have 0, 90, 180. So that means that 210 will come here, because we move in the anti-clockwise direction. So that means that this negative 7 pi over 6 is going to be negative 7 pi over 6. But remember that we don't bring the sign. The sign only tells us the direction. Have you seen that? You don't bring the signs when you are on the cast, because the sign only gives us the direction. Now, the closest x-axis is this pi. So our reference angle is going to be here. So our reference angle is simply going to be 7 pi over 6 minus pi. Then you find out that our answer will simply be pi over 6. So anytime you are asked to find a trig ratio, so once you know this, you can find anything. Have you seen that? Finding the what do you call it? The reference angle is very simple, and the reference angle always gives you a special angle. Have you seen that? So you can use that one to find any trade ratio that you want. So let me ask, is there any questions on how to find our reference angles? Are there any questions on how to find the reference angles? Okay, so if we can find the reference angles, then I should believe that now you can answer question 8,8, and you can also evaluate angles by first finding the other angles by first finding the reference angles, or find the trig ratios of angles by first finding the reference angles. So can we all look at those activities there? And please, if you are having any questions, you pay attention. Our next class is going to be next week, which is going to focus on how to plot trigonometric graphs and how to find. We are also going to look at triangles that are not right angle triangles. So, in the absence of no questions, um, I would like us to bring the class to an end so that you look at what we have done so far today. So that in our next class, we will look at the um, other half of the chapter, unless there are questions. Are there any questions, please? Yes, 2018 384. Yeah, your question.
So say I don't know whether you can be able to start on this reference with our next class next week, because right now we are not sure whether we understand or not, because we have to practice
Okay,
this first
okay,
so we
okay.
can be able to say we understand. Yeah.
That will be good. So that means that next week we are going to have two classes. I don't think one will be enough. So next week we are going to have two classes in succession before you write them. So you can go and practice now. Is that clear? So that next week when we meet, you come with whatever you encountered. Then we tackle that one. Then we start with how to plot quadratic graphs, especially when it is in radians, and also how to look at solve use the sine and cosine rule to solve for triangles that are not right angle triangles. Then I think we will be equipped enough for the exams. Is that fine?
Yes, sir.
Okay, good. Please, any questions again? Please, any questions again? Please, any questions again?
No
Okay,
questions, sir.
okay, good. So, please, in the absence of no questions, that means that we are going to bring the class to an end for today. But next week we are going to have two sessions, and I think it will cover everything for the chapter, so that at least we know that we have completed the units or the modules successful. Okay, so but all the same, you can always send me a message if you are encountering any challenge with any questions at any time. So in the absence of no questions, we are going to bring the class to an end. Thank you very much.
Thank you, sir.